Okay, so question 2. Here we have 3x to the power of 2/3, and that is equal to 12. This is now for question 2, 1.2. Okay. I'd like to solve x for this equation, and I need you to help me with this now. Okay. Where do I start? What's the first thing I should do?
Divided by 3, so.
Perfect. Oh, sorry about that. Divided by 3 on both sides, and 12 divided by 3 is 4. Okay. What can I do now? I now need to get rid of that exponent.
So
Mm-hmm.
must you like put brackets and you put that to the power of 3/2.
Oh, very nice. Yes. Actually, before I do that, I'm going to do some in-between thing just to make it a bit
So,
easier.
can't you also times the exponent by like the base flip? So like times it by 3/2 on both sides.
Yes, that is actually what you were saying.
Yeah, that's
You
what I
were
said.
saying, you apply another exponent, but the exponent is going to be the inverse. So it's going to be 3/2 instead of 2/3. Okay. And when you are multiplying exponents like this, you can see the 3 on top cancels with the 3 at the bottom, and the 2 on top cancels with the 2 at the bottom. So you're basically just left with x. Okay. All of this whole thing here just cancels each other out. And here, this 2, which is a numerator 2, cancels with the denominator 2, and so you're just left with 2 to the power of 3. Okay, and we know that that is equal to 8. So x is equal to 8. Right, question 3. Copy the question down, have a look at it, and then tell me, how would you go about solving this one? First of all, I can give you a hint. This is a trinomial, because we're sitting with 3 terms that we can't add together. And we are going to make use of some trinomial method of solving this. Maybe let me give you another hint. Let me break this up into, see, this is x to the power of half. I'm going to break that up into x to the power of a quarter to the power of 2. Okay? Because x to the power of a quarter to the power of 2 is equal to x to the power of half. So just have a look at this, and then have a look at this. It's the same thing. Okay? Yes, do you have an idea?
So must you take that entire like expression like and put it to the power of 4/1.
Oh no, I think that's going to create a whole mess. If I were to multiply this whole expression with itself 4 times, it's going to create a big algebraic mess. So I don't want to do that.
So can't you just let x to the power of 1/4 equal to k?
Yes, correct. If we let that x to the power 1/4 equal k, then this simply reduces to k squared minus 3k plus 2. And this is something that you are more familiar with. This is a quadratic trinomial. And you guys know how to solve quadratic trinomials. You just open up a set of brackets. You put your factors in, the factors of 2, which is 2 and 1. And in this case, both brackets will have the negative in, which simply means here that k is equal to 1 or k is equal to 2. Okay. Is everyone still following along?
Yes, sir.
Okay. So all we did here is we said let x to the power of a quarter be equal to k. And the moment we did that, then it's like this whole expression became a lot easier. Like from that second line to the third line, that's so much easier. Okay. Now that we solved k, remember you didn't solve x yet. So now you still have to go back and solve x. And we said here that k is equal to 1. So that means that x to the power of a quarter is equal to 1. And we also said here that k is equal to 2. So that should mean that x to the power of a quarter is also equal to 2. You see, now we can do this thing where we multiply by 4/1, where we raise this to the power of 4/1, because now we don't have a whole big algebraic mess. Okay, 1 to the power of 4 is simply 1, and 2 to the power of 4 is 16. So here x is either equal to 1 or x is equal to 16. Okay, and it simplifies nicely. It doesn't complicate the thing even further. So always make sure that the step you are taking, is it going to make the expression look worse, or is it actually going to simplify things? And sometimes, in some cases, I must be honest, when you are trying to simplify things, it must first look worse before it gets better. But in this case, to immediately raise everything to the power of 4 was not going to work for us. Okay. All right. This is question 4. How would we start with such a question? Because you can see how complicated it is.
The square root and the plus 1 over 1, then you can cross cancel the square roots out.
Wait, say again.
See, yeah, there. Then you put it over 1 because it's already over 1. So then you can cross cancel out the square roots. Then you left with 1 over 1 equals 12.
Okay, I hear what you're saying now. So put this over 1 and then cross multiply. So the 1 multiplied by the 12, I get that. And then the square root multiplied by the square root minus 1 and the plus 1. Okay, that's a decent thing to do. Yeah, I think I can do that. Let me just see. Does it work? It should. Okay. Are you guys following what he's saying? You know what? Just to make things easier, I'm actually first going to let that square root be equal to k. I think this is going to help everyone see what's going on. So if I say let the square root of x minus 1 be equal to k, then this is simply just k plus 1 equal to 12 over k. Okay. And now I hear what you are saying. Okay. So you're saying put this thing over 1 and then cross multiply. Okay. So that gives me k squared plus 1 times k equal to 12. Because we cross multiplied. So there we go, equal to 12. I guess this is also a trinomial now. We can factorize this trinomial in order to solve k. And once we have k, like in the previous question, we'll be able to find out what x is. So go ahead now and solve k here. I want you to factorize the trinomial.
K equals -4 or k equals 3.
Yes, well done. Because when you factorize, you get k plus 4, k minus 3. And so therefore this would be k equal to -4 or k equal to +3. Well done. Okay, remember we said that the square root of x minus 1 was k. So this is actually the square root of x minus 1 equal to -4. And this is also, I'll do it in a different color, the square root of x minus 1 equal to 3. Okay. So if we square both sides to get rid of that square root, remember that's how you get rid of the square root, then you have x minus 1 without the square root, and it's equal to 16, which makes x equal to 17 if you take the 1 across. We do the same thing on the one side. Sorry, on the other side. So we square both sides. That is x minus 1 equal to 9, and therefore x is equal to 10. Okay. The thing about third equations, though, let's keep in mind that what we solved here was a third equation. The thing about third equations is sometimes not both answers is going to work out. Okay. Sometimes only the one answer checks out for the equation. To be honest, I think it's in all cases. Yeah, in all cases, only the one answer works out. So I'm going to substitute the 17 and the 10 to see which answer actually works and which answer gives us, you know, something different. The square root of x minus 1 plus 1. Okay, this is the left-hand side. I want to make sure that the left-hand side is equal to the right-hand side. So if x is 17, then this is 17 minus 1 plus 1. That would be the square root of 16, which is 4, and 4 plus 1 we know is 5. Okay, so the answer is 5 on the left-hand side if you substitute 17. Let's do it now on the other side. So here we have 12 over the square root of x minus 1. Okay. And if x is 17, we know that is 16, and the square root of 16 is 4. 12 divided by 4 is 3. So can you see we don't get the same answer? 5 can't be equal to 3. Yeah, and so that must mean that 17 is not a proper solution. So actually, where you wrote your answers, no, you had like x equal to 17. I'd like you to draw a line through the equal to sign like this to show that x is not equal to 17. Because you see what happens here if x is equal to 17. Now let's try the other solution, because one of the answers must work. It can't be that both doesn't work, because then you did something wrong. The square root of x minus 1. So if x is 10, no, so it's 10 minus 1. Plus 1, so that should be the square root of 9, which is 3, so it's 3 plus 1, which is 4. Okay, the left hand side is equal to 4. Let's try it here again. 12 over x, the square root of x minus 1. If x is 10, then 10 minus 1 is 9, so the square root of 9 is 3, and 12 divided by 3 is 4. Okay, so here it does check out. You see, 4 is equal to 4. And therefore, that other answer, where you said x is equal to 10, this answer does work. Okay, the 17 didn't work, but the other answer does work. That's always going to happen like this, where the one answer is going to be invalid, but the other answer is valid. This is for third equations. Okay, so make a note of that. Any questions? So question 1.5, our last equation that we need to solve for today. 5 to the power of 2x minus 6 times 5 to the power of x plus 5 is equal to 0. We need to solve x. Okay, help me solve x with this, for this expression.
So can't you let 5 to the power of x equal to k?
Okay, so I'm going to let 5 You see my screen doesn't work here, so I need to write on that side. Let 5 to the power of x be equal to k. Okay, what will my expression become now if I let 5 to the power of x be equal to k?
So it will be k squared minus 6k plus 5.
Very nice. Okay, and here you see a very common theme in the grade 11 type equations. We are simply going to factorize, solve k. Once we have k, we then solve x. So the factors of 5 is 5 and 1, and we see that 5 and 1 add up to 6. And so therefore, k is equal to 5 or k is equal to 1. Okay. Okay, let's start with the left-hand side first. If 5 to the power of x is equal to 5, then what is x?
X is equal to 1, so
Correct, because the exponent to that 5 is the invisible 1. Okay, if 5 to the power of x is equal to 1, then what is x?
x is equal to 0, so
Yes, and that's because 5 to the power of 0 is 1. So therefore, x has to be 0. Okay, pretty simple stuff. And that's it for the equations.